Okay, so this problem here is a pretty straightforward one. I see angular speed as far as what they're asking for in part A, and I see something in meters per second, which is probably a tangential speed. So, and they're giving me the R. So it says determine the angular speed of the wheel. So in part A, angular speed means omega. So that is our unknown, and we want that to be in radians per second. It says an automobile tire has a radius of 0.380 meters, and its center moves forward at a rate of 26.9 meters per second. Now, here's one thing that's interesting about this. If the center moves at 26.9 meters per second, then the wheel that's touching the ground is moving at 26.9 meters per second. See if I can, I have a wheel here that I'll show you what I mean. So when this is rolling along, the part that actually now in here, that's not moving at the same speed as the wheel, but the part that touches the table, that is moving at the same speed as if I looked at this. Whatever speed that's moving at, that's the tangential speed of the part that's in contact with the ground. All right, so when they say that, I can say that even though what they're giving me is the linear speed of the wheel, that is equal to the tangential speed. That is equal to the tangential speed at the full radius of the wheel. So V is 26.9 meters per second. And so because they are giving me the radius of the full wheel, I know that the linear speed will be at that radius of the full wheel. Now, anywhere else, it's going to be less than that. All right? So it's going to be less than that.
Where'd you get that wheel?
I don't know. It's in the back room. So the R, it says the tire has a radius of 0.380 meters, so I can use that. So with those three facts, the unknown is the omega. Remember our formula. If I were doing this in steps, our four-step problem-solving strategy, that would be step one. Step two would be to then write the appropriate equation that's going to help us solve here, and that's the one that allows us to go from either translational variables to angular variables, and that's V equals R omega. And so the omega is the unknown, so rearrange this to solve for omega, and it's going to be V divided by R. So step 4, we can just plug in the numbers. For the V, we're putting in 26.9 meters per second, and for the R, we're putting in 0.380 meters. Now, when I say 0.380 meters, that's like what a radian is for this size circle. So that's the distance that I would travel if I went 1 radian, which is how I'm going to get my answer in radians per second. Because if you look at this, you look at it and you might say, well, I'm going to get nothing per second because the meters are going to cancel out and I'm just going to get nothing per second. But meter really means when you do this, and I usually don't bother writing this in, but that's where it's coming from. That for this size circle, 0.380 meters is equivalent to 1 radian. It's a weird thing because that's an angle and that's a length. So we can't say they're really equal, but they're equivalent in terms of taking us from something that's angular to something that's translational. So the meters would cancel out, and the radian in the denominator of the denominator would end up coming all the way up on top. And if you solve that, that's going to give you the angular speed of the wheel, which is the same wherever we are on the wheel, whether we're close to the axis or whether we're further away. As long as we're at some, actually, even if we're right on the axis, if we're right on the axis of rotation, that's going to be this number. Even though right on the axis of rotation, we wouldn't even have a V. There'd be no V there. There'd be no tangential speed, but every place on the wheel there's an angular speed. So what do you get for that? What's the answer for that? What is it? 70.8 radians per second. And then in part B, it just says, well, find the tangential speed at a point located 0.21 meters from the axle. So that's not on the end. That's not where the wheel is touching the ground. It's somewhere inside of that. So it's going to have to be a number smaller than 26.9. So I can go right to, in part B, right to the formula. V equals R omega. But the R is different than the R for the full wheel. We're only 0.21 meters away from the axle. So we put 0.21 meters times the number that does not change no matter where you are on the wheel, and that's the angular speed. So that's 70.8 radians per second. So even if they had only asked me to solve for part B, I would have had to have solved for part A so I could get the angular speed that I could then use for part B. And if you multiply those together, what do you get? What is it? 14.87, so we'll say 14.9. Again, this is another problem where that's really meter per radian, right? So the radian part would cancel the radian, and I get my answer in meters per second. So tangential speeds are in meters per second. Angular speeds are in radians per second. So meters per second, radians per second.